My name is Richard Wheeler, and the following presentation takes a brief look at a proof-of-concept low-code machine learning development environment that enables project collaboration via extended reality. This is my dissertation project as part of my MSc Data Science degree at Cardiff Metropolitan University. As described by one of the participants of the feasibility study questionnaire for this project, whose role is as a chief technical officer, when asked if an application that allows teams to interact with and evaluate the output from machine learning model development without requiring them to have any programming knowledge would be useful within a project, they replied yes, stating that models are often driven by business requirements from users without the technical knowledge to understand the underlying modeling. The aim of this project is to develop a proof-of-concept application that not only allows the rapid development of machine learning models, taking the user through the data analysis and model development stages within a low-code development environment, but also produces the visualizations and data required for not only explaining how the model was developed, but also how it works. All of this culminating in the creation of visual assets that are then unified within a single collaborative virtual reality environment. The first part of the solution is a machine learning model low-code development web application that enables the user to upload a dataset, select the model type, either classification or regression, and then takes them through the stages of data analysis, model development, and explainable AI. In the rest of this video, we are going to look at an existing project developed using the application for a classification model that predicts mortality caused by heart failure. Within the data analysis section, the user has access to the application's data configurator, which enables them to make changes to and create new attributes from the original dataset in order to prepare it for use in developing a machine learning model. To assist the user further, this section also contains data reports showing both the statistical data for each attribute within the dataset, as well as the correlations and interactions between those attributes. The application also generates a selection of visualizations created from the dataset which can be used for further analysis. Once the data has been prepared, it is then passed on to the machine learning model development section of the application. Within this section, the user is able to configure a number of data pre-processing options that will be used as part of the AutoML development environment. The application will then generate a data report comparing the training and test data that will be used for modeling, along with a model comparison table showing all the models that were trained and tested, including performance metric scores for each. The application uses this AutoML environment to train and test a number of machine learning models from multiple libraries, including scikit-learn, XGBoost, LightGBM, etc. The model with the best performance scores is selected and hyperparameter tuned before a selection of visualizations are created for analysis of the model's performance. The user is also able to change the selected model to any of those shown in the model comparison table, change the metric by which the model is optimized during hyperparameter tuning, or select an ensemble method for improving performance. Finally, the user can review the performance of the model by viewing predictions made using unseen data that the model was not trained or tested on with during its development. When the user is happy with the final model, they can then move on to the explainable AI section. Machine learning models have been described as black boxes where it is not always clear how they generate their output. This section uses SHAP plots, shapely additive explanations that are generated using the unseen data predictions to explain the model's output and the effect that the data has on how those predictions are generated. The final section within the application is the project log showing each change the user has made either during data analysis or model development, for example, configuration changes during data analysis, and final model descriptions including parameter settings and accuracy scores on the unseen data. From here, the project files and the final model can also be downloaded. All of the project files are also saved locally on a server so that they can be accessed again at any time within the application, as well as being prepared for use within the collaborative virtual reality environment. This VR environment was developed to enable project teams to analyze, discuss, and make changes to the model without requiring them to have local access to files, programming knowledge, or to even be in the same location. This proof of concept environment consists of 2 rooms split into 4 sections. Room 1 contains all of the assets created as part of the data analysis, including the full project log, both the original and final modeling data, the final Suite Viz and Pandas profiling data reports for that modeling data, and all of the generated data visualizations. In the second room, all assets created as part of the model's development, including the AutoML environment configuration, the model comparison table, and the final model's tuning scores. A Suite Viz data comparison report for the training and test data used for model development, and all of the visualizations generated for analyzing the performance of the final model. The final section in this room contains the Explainable AI Visualizations, including a summary of the importance for each attribute within the data on the final model's predictions, and the unseen data predictions along with related force plots for the first 10 predictions showing exactly how the data was used by the model in generating its output, and a full explainer plot showing the same force plot data but for every instance within the unseen data. As we return back to the original room, there we are able to see the final section where users are able to access the web application. From here, as described previously, they are able to make any changes that are required to the project. This ends this brief presentation for this proof of concept application. Thank you for your time. Please leave your thoughts in the section below.